Hi guys, good evening. So in the last session, we saw about the HA concept. Now today what we'll do is we will see about transparent firewall concept. Okay. We'll see about transparent firewall concept. So I believe you're already aware what is a transparent firewall. Anyone who would like to tell me what is transparent firewall? Yes, please. Anyone would like to tell me what is a transparent firewall? No. So basically, transparent firewall is a deployment of your firewall as a L2 device. Okay. So you can also consider it as a L2 firewall. Now, in which scenario you will use this firewall in the L2 mode? So let's consider you already have a router or a firewall here. Consider this can be ASA or a router. Okay. And this is handling lots of VPN configurations and it's handling so many other ACLs and all these things it is handling here. But the thing is that this is not capable of L7 filtering. Okay, this is a router on the edge, which is not really capable of L7 filtering. Okay, so in that case, what will happen? You have your inside network. Okay, and then this is connected to the router. And then this side we have actually. This is how we are connected. This is the switch. Then we have our inside systems. And this one's here. This is if we take C1, let's just PC3. Now you want that, okay, right now the traffic should pass through like right now this traffic is passing through the router, and the default behavior of router, we all know that what is the default behavior. By default, router will allow all the traffic. So if somebody is going from inside to outside, will be allowed, and if they are downloading some malicious files and all, even that will be allowed. Okay, because router does not perform inspection based on layer 7. Okay. Now let's consider that this is the interface of 3051. This is the interface 3052. This is the interface 3053. Okay. Now, and this is PC, which is PC1 having an IP address 10.1.1.1 with the MAC address and 1. This is the IP address. With the MAC address and 2. Okay. Here we have an IP address 10.1.10 with the MAC address. Okay. M3. Okay. Now what? That here in this way, as of now, this PC1 will have a ARP cache. In the ARP cache, it will have an entry of IP and MAC address. Okay, so it will use the gateway MAC address, which is 10.1.1.10, to communicate with other network. Okay, and here in the stage MAC address will be what? M3. Correct. And here the ARP cache will be there, in which the same information will be there. Okay, so it will maintain the CAM table. Okay, so in the switch CAM table, we will have information about what host has what MAC address connected and to which VLAN it belongs. Okay, these are all the information available inside the CAM table of the switch. So initially it will have information that V0 by 1 is having the MAC address M1 belongs to VLAN. So let's consider this is the default VLAN 1. Then we have V0 by 2 having the MAC address M2 VLAN 1, V0 by 3 having the MAC address M3 VLAN 1. This will be the information. Okay. And based on this CAM table information only, your switch will forward the packets. Correct? Now let's say in this scenario, you cannot bring the router down. Okay, you cannot bring your network down because normally what you can do is in place of this router, you can place a FTD. Correct? As an L3 device, I can keep my FTD here in place of this router. But for this reason, what I'll have to do, I'll have to bring down my network. I have to disconnect this router. I have to connect my FTD and then I have to do all the configurations, whatever the configurations are there in the router, same configurations I have to do it on the FTD. Correct? So I have to do this. But if I don't want to do this, okay, if I don't want to bring my network down, my organization cannot afford to bring downtime in my network. So if I cannot disconnect it, another ways I can deploy it here in between this. Okay, as a routed mode, if I'm see in the routed mode, what happens? Two modes are there, right? We have two modes. One is the routed mode, another one is the transparent mode. Okay, so in the routed mode, your firewall will behave like L3 device and can be used as a gateway. Okay, your firewall can be used as a gateway. While in case of transparent mode, your firewall will behave like L2 device and cannot be used as a gateway. Okay, the firewall cannot be used as a gateway. Okay, so if I'm deploying the firewall in the L3 mode, in that case, I can use it as an edge device. In that case, I don't need this router. I can replace it with the FTD. Okay, consider this is my FTD. So in this case, if I'm using it as an L3 device, in that scenario, I can replace it. But I have to bring down my network. And if I want to use it somewhere in between, so I want that I don't have to go and change the gateway on the clients. So what I do, I can put it in transparent mode. But even if I'm keeping it in transparent mode and I'm keeping it between the switch and the router, still I have to bring down my network for some time because my entire traffic will pass through the FTD and I have to configure all the policies that I want to configure. Okay. So this is again an issue that there will be a downtime, not a very long downtime. Okay. Not a very large downtime, but still there will be a downtime in my network. Again, I cannot afford to have a downtime in my network. So I cannot deploy it here as well. So what will be the best approach? The best approach will be to deploy it on the switch itself. Okay. So we have to deploy it over the switch. So here how we will deploy it? We will connect two interfaces of the FTD. One interface we will consider it inside, another interface we will consider it outside. Okay. This is how we will connect the FTD. And this is the interface, let's say, for example, 0 by 5. And this is 0 by 4. Okay. And then on this FTD, what I'll do, first of all, I'll change the mode of this firewall as a transparent. The first thing I'll do is I'll change the mode of this firewall as transparent. And another thing I'll do is I'll configure something called as DVI. Okay. I'll configure bridge virtual interface. Bridge virtual interface. Okay. So basically, this bridge virtual interface is what? It's a kind of a group of interfaces that are bridged together. Okay. So I'll configure DVI here, and that DVI will do what? Will basically kind of create a bridge between these two. Okay. These two interfaces of the FTD, let's consider this is the 0 by 0 interface. Okay. of the FTD, and this one V0 by 1 interface. So these two interfaces will be bridged. Okay, so what will happen? Whatever the traffic is hitting, okay, whatever the traffic is hitting on this interface of the firewall will automatically be sent over this side. And if some traffic is hitting on this interface, it will be sent on this interface. This is how the bridging will work. Okay. And for management of the firewall, because this is not a layer 3 firewall and this is not acting as a layer 3 device. So here, what will happen for management of the firewall? We will configure an IP address also. On this bridge group interface, we will configure an IP address. Okay, this will be done. But still, even if I will configure the bridge virtual interface and I'll make these two interfaces as a member of this bridge group, okay, I'll do all these things. Okay, I'll configure it in the transparent mode, create the bridge group, assign the IP address and everything. But still, will my traffic pass through the firewall or not? Think about it. Will my traffic pass through the firewall?
No, sir.
No. Why?
Because we create to VLAN.
Yes. Okay. So the traffic will not pass through the firewall. Why it will not pass through the firewall? Because everything belongs to the default VLAN only. And since everything belongs to the default VLAN, according to the CAM table, whenever PC1 will want to communicate with the gateway, okay, whenever it will use the M3 MAC address, always it will be sent on the interface V0 by 3. That means the traffic will travel like this. Everybody agrees with this? Yes or no?
Yes, sir.
Because according to the CAM table entry, what will happen? That when this PC1 will generate a packet, okay, let's say PC1 wants to communicate with the router or anybody on the internet, so it will generate a message here. In that message, it will say source IP, destination IP, source MAC, and destination MAC. Source IP it will give. That source IP is 10.1. Destination IP, let's say 11.1. Source MAC address it will use itself MAC address, which is M1. And whenever a PC wants to communicate with a different network, always it will use gateway MAC address. Okay. Then what will happen? Sorry, gateway MAC address is M3. Now, once this message goes to PC will try to forward to the switch. It will look where? It will look at the CAM table that where is M3? V0 by 3. So automatically it will forward it here. The traffic will never go to the firewall. Right? So what we have to do here? We have to go and create VLANs here. Okay. So what we'll do? We are going to go and create VLANs. So two VLANs we will create here. Okay. One VLAN on this side. Another VLAN on this side. So these are the two different VLANs that we are going to create. So let's name it. This side I'll create VLAN 10. Okay. And this side I'll create VLAN 20. Okay. Now these two interfaces 3 and 4 they belongs to VLAN 20 and 1, 2 and 5 they belong to VLAN 10. Okay. So now how the CAM table will look like? Understand here. Now the CAM table entries will change. How it will change? They will change to that okay. According to VLAN 20 or VLAN 10, in the VLAN 10, 3 interfaces are there, V0 by 1, 2 and 5. Okay. So it will say V0 by 1. What is the MAC address? M1 MAC address belongs to VLAN 10. Then after interface V0 by 2. So V0 by 2 interface, MAC address M2 and VLAN is 10. Then if you see that through the whenever this PC will try to send an ARP, the ARP is a broadcast. Okay. So it will go here, then switch will forward it here as well as here. And whatever the ARP will come from this side will go here and will go to the router. Router will respond because whenever PC1 will try to communicate, it will try to want to get to know the MAC address of your 10.1.1.10. So router will respond. That response will come to this interface. So switch will learn the MAC address M1, MAC address M3 through which interface? V0 by 5 interface. Switch will learn the MAC address through which interface? V0 by 5 interface, right? So here what will be the entry in this case? in this case, the entry will be okay that through the G0 by 5 interface, MAC address entry has been learned in the case of VLAN 10. These will be the entries. Okay. Then now next thing is what about VLAN 20? So on VLAN 20, we have only two interfaces, V0 by 3 and 4. So it will say that okay, V0 by 3 has the MAC address and 3 in case of which VLAN? VLAN 20. Then now M1 and M2 MAC addresses, they will come onto the VLAN 20 through which interface? See here, through which interface they will enter the VLAN 20? G0 by 4, right? So which will make an entry that okay, G0 by 4 has the MAC address M1 on the VLAN 20. Then same way, G0 by 4 interface has the MAC address M2 to the VLAN 20. Okay. Now this is how the CAM table will look like. Once this is done, now if your PC1 will generate a packet, see how the traffic flow will be. So this PC1 will generate a packet, and in the packet, the PC1 will say source IP, destination IP, source MAC, destination. Source IP will be 10.1, destination IP, let's say again some other network is trying to communicate, source MAC address M1, and it will use gateway MAC address M3. Then after it will send the packets to the switch. Switch will see that this packet is entering through which VLAN? VLAN 10. What is the destination MAC address? M3. So in the VLAN 10, M3 is available where? G0 by 5. So this traffic will be sent to FTD. Then this bridging interface will do what? It will forward automatically this traffic on the other side after inspection and filtering. Okay. So this message will come on the other side, G0 by 1 interface. Through G0 by 1 interface, it will enter the VLAN 20. Now, in the VLAN 20, switch will check that, okay, destination MAC address is what? M3. Now, in VLAN 20, M3 is available on which interface? G0 by 3. So the traffic will go to the router. Router will check the destination IP address and forward the packet to the internet side, right? Now, see how the response will be. So when router will send it on the outside, the router will use a MAC address of its own. Okay. But when the reply message will come to the router, see how it will look like. Source IP, destination IP, source MAC, destination. Now source IP will be 11.1, destination IP will be 10.1. Source MAC address, when router will forward the packets to the client, so it will use source MAC address as its own MAC address, M3, and destination MAC address. Router already knows what is the destination here, 10.1. So looking at the ARP cache, router will say destination MAC address is M1. Okay. Now this is the reply message. This reply message will come in the VLAN 20. In the VLAN 20, switch will check that in the VLAN 20, destination MAC is M1. M1 is available on which interface? V0 by 4. So this traffic will be forwarded to the FTD. FTD will inspect it and then forward it to the other side. In the other side, it will enter the VLAN 10. Now in the VLAN 10, switch will check where is M1. So in VLAN 10, M1 is available on V0 by 1 and the packet will come here. Is it clear how it will work? How your transparent firewall concept will be there? Yes or no? Yeah, it's clear, right? All right. So now what? See, in this case, what we have to do is we just have to put the firewall in the transparent mode and we just have to configure this DVI. And third thing is we have to configure VLANs. That is your entire transparent firewall concept. After that, in the FTD, whatever the policy you create, that is same like useful. Okay. So let's go and do it directly in the lab. Not to the lithium, the vanilla, the firewall, save it. Now here I'll need one FTD to firepower. In the device I'll use 6.2.0. This is the FTD and I'll use FTD underscore T for transparent. Okay. And here firewall is we will use. Okay, CPU I'll assign it to each so that it will work faster. Okay. Then I'll connect the switch here. Create inside switch. This is the inside switch. This is our transparent FTD. Okay. Then after one more switch I use for the management side. Management switch. Okay. So FTD management interface I will connect to the management switch. Okay. And then I will connect two interfaces of the FTD, that is V0/0 and V0/1. Okay. So V0/0 I will use it as an inside interface and V0/1 I will use it as an outside. Or as per this diagram, if you want to go, then we will use V0/1 as inside, V0/0 as outside. Okay. Then with this management switch, we will connect. Okay, let me bring up the FTD, start it. Okay, so that meanwhile we design the lab, FTD will come up. Now here my FMC will be connected through the management cloud only. So let me just go and not the node. We just want to select it for FMC, industrial management cloud, and this is for FMC. Okay. And same way management PC will also come here to the same. Okay, so I'll just take an example of VPC, which will be working as a management PC. Management PC. Okay, this is a management PC. Okay. Then after, I will have one inside router. Okay, to keep the lab, like consume less resources. So I'll use only one router on the inside. Save it. This is inside R1. Then we will have one gateway. Okay. So we need two routers. Again, I will use. These are two more routers. One will be my gateway router. So let's call it gateway. And edit this one, and this one I'll configure it as the outside app. Okay, let's connect. Outside. directions. Now IP addresses, we will keep them same only. Okay, like on the inside, network values 10.1.1.0/24. Bold, this is up inside info. Parallel, parallel, and then on the outside we will use same 11.1.2, and on the management side we will use 10.3.0. So in this case again, here on the FMC IP address will be 10.3.62. So this management PC IP address I'll keep it 10.3.1. Okay. Then inside R1, 10.1.1.125. Then I have gateway, gateway IP address I'll configure 10.1.1.10. This will be 11.1.1.10. Okay. And here this will be 11.1.1.125. And on the F3 management interface, IP address I'll configure is 10.50. And we will configure one bridge virtual interface. Okay, so here we will configure one DVI. On the DVI, let's say I will use one IP address, 10.1.1, something like 50. Okay, this is the IP address I'll configure on the bridge group. Okay, DVI means the bridge group virtual interface. Okay, so let's see about actually whether it's up or not. Okay, almost up. Meanwhile, this is coming up. Let me start all of the devices, start all the nodes. Okay, so I'll just power it off. I don't want this right now because my management PC will also come through this interface because this is a management cloud. Okay. Now what? Let me access the FMC. Is it up or not? First, I need to check. FMC is up, so I can go and I can say 10.3.2.62. This is our FMC. Username, admin, password is just 0150. Login. Not now. Go to the devices and I'll remove all the devices that are present right now. Okay, so this HF here, I'll delete this HF here. while F3 is on, we can try to do the basic configuration. Admin 601.160.150. Admin 150. Okay, accept the license agreement. Set new password 60150. 60150. Then V4, yes. V6, no. Manual IP address, yes. Management IP address will be 10.3.3.10. Subnet mask 50. V4 V6 10.3.3.1.1. Domain name FTP -C. Transparent F3. DNS server, none. Domain names, none. Okay, now this will ask you whether you want to configure the firewall in the routed or transparent mode. So this time we will configure it in the transparent mode. Okay, so let's see. Transparent mode. Okay, so configuring the firewall mode. And before this, let me do one thing. I'll do the basic configurations of inside R1, gateway, and outside R1. Okay, so inside and outside configurations we already have in our basic configuration. That is there on the desktop. Okay. So inside R1 and outside R1 configurations, I'll directly copy paste, access it in the same inside R1. Then I have outside R1. Then I have my gateway. Okay. And then on this inside switch, we will configure two VLANs. So those VLAN information. So here that's the no, and this is just the switch. Okay. So over the switch, we will configure two VLANs, one on this side, another one. Okay. So this side you will see this is VLAN time. This side we will configure VLAN 20. Now we already have the inside R1 and these configurations. We'll copy the inside R1 configuration. This is inside R1, and then I need outside R1 configuration. Okay, this is come. Then this gateway configurations I have to do manually. On the Z0/0 interface, I have an IP address 10.1.1.10. Z0/1 interface, I have 11.1.1.10. So let's do this configuration on the gateway. Here we go. This thing gateway interface is 0/0 IP address 10.1.1.10 356 down 0/1. This will be 11.1.1.10. Okay. Now see, if I will test the communication from my inside R1 to outside R1. So you can check it will ping 11.1.1.175. So I should have this communication. And you can see I have this communication. Why am I having this communication? Because the default behavior of router is what? To allow everything. Now, once my traffic will start passing through the firewall, my communication will stop. Then my communication will be allowed only if I will create a allow all traffic, okay, policy. So let's go and configure our firewall. So minimize it. Go to the FNC. This is FNC. What about FTD? And in the FTD, you can verify the mode, that in which mode your FTD is. Show firewall commit. And you can see firewall mode is what? Transparent. Okay. Now what? Just add the manager here. Configure manager add. Okay. And manager IP address is 10.3.6.2. Key is 60. Then just click here, add device. Usually like we add the device. IP address is 10.3.10. Display name, FTD bus, transparent, registration key is this two. The policy that you want to apply. So I can apply this block all traffic policy. Okay. Right. So now my device is getting registered. Device is being added. And also we can verify here. So managers. It started registration. So you can see registration is completed. Okay. Once the initial deployment will take place, then after communication with that is established. Now discovery from the device is started. Okay, so what will happen? That it will synchronize the configurations. Meanwhile, this is happening. Let me go to the policies and let me check what kind of policy right now is available. Let's go to the access control. Edit it. Like if I'm having a rule or not that I want to test. Or let's just yeah, we have a rule allow all traffic. So let me just delete this rule. Okay, so right now there will be no rule. So by default, our traffic should stop. Okay, that means my communication should stop. In discovery from the device is in progress. I'm going to start with one thing is will not get done. Language edit policy access control. Let me delete this policy also. I don't want to delete it. This is space management. Add it. Let me say configure manager. Again, done. Now let's add the device. Devices 10 is transparent, registration to create access control policy, that is lock policy, graphic, save, enable all features. So if you want to enable or do not enable, that is totally fine. Let's save it. Because those three licenses will be required when you want to perform else I will continue. Okay. So later on also you can enable it. Registration is comfortable. Communication has been established. The story can follow. Yes. Between the query and OpenSea, the communication happens. Once this will be done, then Um, after this, we will try how to click. So guys, I'll do one thing. I'll add it. Okay, and we'll continue this tomorrow. Okay, it's fine, right? Because multiple times it will fail. It happens. Okay, you try to add it again, it will fail. You try to add it again, it will fail. In these labs, it happens actually your side-to-side VPN as well as your uh, this transparent firewall from everything will go fine and then they will just drop the connection. Very active. So mount it. Here it says complete, but actually it's not complete. Yesterday also we saw the same thing like that. It will take multiple times to configure. Then everything is go. Okay, this is not happening right now. So what I'll do is I'll add this firewall in the FMC and then tomorrow we'll continue. Okay. Right now, multiple times it's failing. Clear, right? Theoretically, you understood the concept, right? That how our lab will be and what we have to do. Only 3 steps will be there. One is configure firewall as transparent. Second one, create the bridge virtual interface. And step 3, create these VLANs. That's it. Okay. So once firewall will be added, then after we can do this one. So I'll add it so that tomorrow we don't have to wait. Okay. We already tried 3 times, but it's failing again and again. Okay. So I'll add it and then tomorrow we'll continue. Okay. We could do it today, but actually I have to take a dinner, so that's why. Okay. All right, guys. Then I'll see you tomorrow. Have a good night.